All right, welcome. This is the IM2 Distance Learning Packet Solutions and Tutorial. Here we have week 2. This is for the date of 413 through 417. This is the first page, okay? All right, so the first one. Which expression is equivalent to this? What's happening here is you see a binomial here timing another binomial. So essentially what you're doing here is multiplying binomials. If you need a refresher, I have some notes here that you can take a look at. Here's the first binomial, x plus 2. It's going to be multiplied by the second binomial, x plus 5. And how they're going to multiply is using the distributive property. Watch what happens, okay? First of all, the x is going to be multiplied to x and x plus 5. That's what happens here. Okay, that was the first multiplication. Then I'm going to do this in, let's see, green. The 2 is going to be multiplied to the x, and the 2 is going to be multiplied to the 5. That's what this is. Okay, so that's what's occurring. So x times x becomes x squared. X times 5 is 5x. 2x plus 2 times x is 2x. 2 times 5 is 10. Then they combine the two like terms here. The 5x and the 2x become 7x. Okay? So same thing here. That's what we're going to do. Okay? We're going to distribute. All right? So x times, so you have 2x times 3x. Then you have plus 2x times 5 plus, then you have the bottom part, negative t, because negative 5, negative t, because this is negative, right? Times 3x plus negative t times 5, negative t times 5. All right? So what do you have? You 2x times 3x becomes 6x squared because you're multiplying these, so the exponent becomes x squared, plus 2 times 5 is 10. X is just there. This is negative t 3x, so that's negative 3tx. Then you have plus negative, because this is a negative, t5, so that's 5t. Okay, all right. So it should look something like this: 6x squared plus 10x minus 3tx minus 5t. You can't technically add these, but there is a like term here. The 10x, the 10x and the negative 3tx have something in common, okay? What you could distribute out here is actually the x, all right? So you pull out an x here, this becomes a 10, this becomes minus 3t, all right? Everything else stays the same, okay? So your answer would be the fourth one, all right? Next, number 2, okay? Again, here you're going to multiply the polynomial. So you could do it this method, or I'm going to show you the method called foiling. Okay? So right here, the first term, x times x becomes x squared. Then you have your outer, right? X times the outer one, which is the blue, which is the 2, becomes 2x. Then you have your inner, then you have your last. Okay? Foiling is just an easy way of remembering multiplying two binomials. Okay? But if you want to know a more general, you're just distributing. All right? So we can apply this rule if we want. All right? So let's essentially FOIL. Okay? All right? This is our first. So 2n times 5n, that becomes 10n squared. Then you have your second term, which is your outer, which is in blue, right? 2n times 6, that becomes 12n. Then your green, which is your inner, negative 3 times 5n becomes negative 15n. Then you have your purple, which is your last, negative 3 times 6. Negative 3 times 6 becomes negative 18. Write this all together now because 2n minus 3, 5n times 6. When you multiply this, it gets you all of this together. So you have your 10n squared plus 12n minus 15n minus 18. Notice these two can combine. So 12n minus 15n becomes negative 3n minus 18. All right, that would be the answer here. All right, so again, this is just using the formula method. All right, for 3, you are going to do this yourself. Okay, you're going to look at example 1 or 2 for help. Good, because it's the same idea. All right, here, this time we're adding, then we're going to subtract some polynomials, okay? So what I have here on my right-hand side are some notes for you, okay? So how can you find the adding of these? So look, you see how you have your 3x squared? The like term is your x squared. So here, when they add it, this is your adding all the like terms of x squared, right? Then you have your, I'm going to box this, right? Your x and your 4x. So this is, okay, this is when you're adding your x. Then lastly, right, I can make this a triangle. This is a triangle. This is your triangle. Lastly, they're adding the triangle parts, right? The negative 6 plus 10, right? That's ugly. So that's essentially what they're doing, okay? You have your 3n squared going to be multiplied with your x squared because they're like terms. Then you're going to have your x and your 4x add because they're also like terms. Then you're also going to have your negative 6 and your negative 10 add because they're like terms. So making sure you're just adding your like terms. Okay? So in this case, 4x squared and 9x squared, these are like terms. 4x squared plus 9x squared because these all belong to the x squared family. Okay? So you could do this, right? You can do this. This 9 plus 4 becomes 9, 10, 11, 12, 13. And they belong to the what? X squared family. You can do that. Okay. Next, you have your negative 5n and you have your negative 2n. Okay. So plus negative 5x minus 2x, right? That's what these two. Now you can add these. This gets you negative 7x. All right. Can you add these two together? Can you do 13x squared, all right, plus negative 7x? No, you can't add. This is a power of 2, and this has a power of 1, right? The degrees are different. Or if you want to think about this in terms of the degree, if you want. This is degree 2. This has a degree 1. It doesn't work. You can't add these. Okay? All right. Okay. Then let's do the last part. 6. 6 left untouched, so it was just plus 6. Okay? So it was just 13x squared minus 7x plus 6. That's just another way of writing this. Okay? Then you have this part, right? You have your subtract 11x minus 3. Okay? I have some notes here. Notice that the way they subtract is the same thing as before, but this time they distribute this negative 1 here. Do you see how the negative 1 is distribute? That's how they get a negative 3x squared. Negative 1 times negative x gets you a positive x. Do you see the negative 1 here times the negative 8 here becomes a positive 8 here, right? So they distribute this negative 1. So negative 1 times 11x becomes negative 11x. Negative 1 times negative 3 gets you a positive 3. Okay? Now rewrite everything else. Now it behaves the same exact way. Okay? 13x squared remains the same. Negative 7x plus negative 11x becomes negative 18x. Okay? Plus 6 and plus 3 becomes plus 9. Alright? There you go. Okay? Just making sure that when you add them together, make sure you're adding the same powers. Okay? There you go. This is your final answer. Okay? Lastly, here, like before, you're gonna. I can even bring down the foiling notes here. Okay. All right. Because here we're multiplying. All right. So let's multiply. Okay. So the first one. Okay. ax times cx. So that's interesting. Um, So this becomes ax times cx. Oh, that's an ugly way of writing it. Cx. Okay. Oh, that's x. Right. Plus. Plus blue. Ax times d. So ax times d. Okay. Plus green. B times cx. So b times cx. Okay. Just move this over to the right a little bit. Then we have add. Lastly, b times d. Okay. And now you can multiply this. A x times cx becomes ac. Nothing happens to it, but you have two x's, right? So it becomes x squared. Okay. Next, ax times d. Nothing happened to that, so that's just axd. Same thing here. Just bcx, and you end up with bd. Okay. Nothing happens here. There's no like terms here. So you can just write this as acx squared. axd, bxc. They have the letter D, x as the like term. So if you pull out an x here, it becomes like, look, if you pull out an x here, it becomes AD. And if you pull out an x here, it becomes plus BC. Okay, just making sure that you have the x right here. Okay, you're just distributing it out. Plus, in the end, BD. Okay, this should look like exactly like this. Okay, there's just an extra step of when you combine these. All right, so there you go. That's it. These are all your solutions for the first page of week 2.